So in previous videos, we've looked at how to modify the shape and location of a sine or cosine graph by either using amplitude. So let's see, we had amplitude, period, and a vertical translation. So there's one more way we can modify, in this case, the location of a sine or cosine function. And this is also going to work for the other four trig functions, but today we'll focus on sine and cosine. Or in this video, we'll focus on sine and cosine. And that's a horizontal translation. So if we have this y equals sine of x minus c, this c here is the horizontal translation. And we've seen this before. You know, if we have y equals the absolute value of x minus 2, I mean, this is the absolute value function shifted to the right 2 units. So it's the same thing here. So let's look at an example of how this would work. Let's sketch a graph of y equals the sine of x minus pi over 4. So if we were to just sketch sine of x, let's go ahead and do that. So here's 1, here's negative 1, and I'll dot this one in. So the sine of x looks something like this. So there's 2 full periods. Y equals the sine of x. Now if we have a minus pi over 4, just like we shifted this absolute value to the right 2 units, this is the same idea. Because it's a negative, we're going to shift it to the right, and we're shifting it to the right pi over 4 units. So we have to think that we're going to take this whole graph and just move it over pi over 4 units. So the first part, instead of having 0, it's pi over 4. And so it's going to follow a little bit to the right of each one. And so if we were going to sketch it, and there we go. Now we do have to label where it crosses this axis of oscillation. And so to do that, you just add pi over 4. So if this, for example, is pi over 2, then we would add pi over 4, and then this would be 5 pi over 4. Actually, that's pi, sorry. So pi plus pi over 4 is 5 pi over 4. This is 2 pi. So 2 pi plus pi over 4 is 9 pi over 4. This would then be 3 pi, so this is 13 pi over 4. And then this is 4 pi, so this is going to be 17 pi over 4. And there is a good sketch of the graph y equals the sine of x minus pi over 4. Let's do another one of these. We're going to sketch a graph of y equals a negative 1/2 times the sine of pi x plus pi over 2. Okay, now when you have both, so we have 3 things going on. We have the negative 1/2, which is going to be a reflection over the x-axis and an amplitude of 1/2, so we're shrinking it. We have a period change, and so we're going to have to figure out what that period is. And then we also have a horizontal translation. Now you have to be careful when you have a period change and a horizontal translation. That can be tricky about, well, what does this really look like? I mean, we're changing the period, we're shifting it over. And so when that happens, the first thing I like to do, so let me rewrite this. We have -1/2 times the sine of pi x plus pi over 2. What I like to do is I like to factor out whatever this b term is first. So we're going to have a -1/2 times the sine of pi times x plus 1/2. And so then I can see, once we take into account our period change, how much we're shifting it over to the left or right. And so in this case, we're moving it to the right 1/2 unit. Okay, so let's get our period. Our period is equal to 2 pi over b. So that's 2 pi over pi. So we have a period of 2. So let's first sketch y equals a -1/2 times the sine of pi x. That might be a little bit easier. We'll do a dotted line for that. So here's 1, here's -1. Now normally sine starts here and goes up, but we have two things going on. First, it's an amplitude of 1/2 instead of 1, so we're shrinking it, and then we're starting negative. So this is probably going to look something like, so let's see here, 1, and now we have a period of 2, 3. So it's going to look something like that. So this is 1, 2, 3, 4. And we're going from a -1/2 to 1/2. Good. Now we can put in our horizontal shift or a horizontal translation of 1/2. Now because it's a plus 1/2, we're moving it to the left 1/2. So here is -1, and so this point now is going to start here. So everything's getting shifted over. So this point's here, here. I think that's going to be good. There we go. And then we do have to label where it crosses that axis of oscillation. So this is -1/2. This is 1/2. This would be 3/2. This would be 5/2. And this would be 7/2. And so there's a good sketch of y equals a -1/2 times the sine of pi x plus pi over 2. All right, so we have this final transformation that we can perform on a trig function, and in this case it's the horizontal translation, and that's when we either add or subtract a number inside that trig function.